All right, now on to Biostats Part 3, Study Types. Make sure to like and subscribe if you haven't already. So starting off with, let's talk about the Kaplan-meier curve. Essentially, this will be a curve or a graph that will track survival of different groups over time. So on the y-axis, you have your percent survival, and on your x-axis, you have a measure of time. All right, now talking about the different types of studies, let's talk about a cross-sectional study. So a cross-sectional study will use data from a population at a single point in time, so think of it as a snapshot, to assess the prevalence of an outcome or exposure. So again, it's a snapshot in time. It only measures the prevalence. You can't look at any measure that looks at something over a period of time, so you can't calculate incidence from cross-sectional studies. And cross-sectional studies can help you identify associations, but cannot establish causality because you don't have the temporality component. One example of a cross-sectional study would be a survey of 10,000 people to find the prevalence of type 2 diabetes in association with BMI, but you can't say whether or not BMI caused diabetes or if diabetes caused elevated BMI. So again, you can use this, though, for an association to think about tests to run in the future. So that's a cross-sectional study. Again, snapshot in time, and it can assess for the prevalence at that point in time. Now, a case control study is when you will compare the group with the disease compared with the group that doesn't. So the thing to remember for a case control study is you first find the cases of the disease. So case control studies are the preferred study type for rare diseases, and you can use the results or the 2x2 table from a case control study to calculate odds ratio. And the way you calculate odds ratio will be A times D divided by C times B to calculate the odds ratio. So an example of a case control study would be if any of you are like comic fans or X-Men fans. There was a guy that assembled all the X-Men, Charles Xavier, and he used his telekinetic powers to find all the X-Men. So here you can think of Charles Xavier here finding all the mutants or to find the X-Men. So he's looking first for the cases, and then once you have the cases, you'll find an appropriate control group. On the other hand, let's talk about a cohort study. So with a cohort study, you'll compare a group that has an exposure with the group that doesn't have the exposure. So usually a cohort study will be prospective. If you think about a cohort of students, so say you have 10 students. I know you get to watch me draw these beautiful stick figures. Maybe I can draw them like this. How many are we at? 7? We'll draw 8 stick figures. So this was like our cohort. And then they all I spray them all with, this is me. I spray them all with, some kind of exposure, pesticide or something. And then you'll look at how many end up developing some kind of adverse effect or complication or something. So again, with a cohort study, you are following patients that have a exposure or a particular risk factor. You're not looking for the cases themselves. You're going to look for how many people with the exposure ended up developing an adverse effect. So with a cohort study, you can calculate the relative risk. And you can calculate risk because you're actually looking at a particular exposure and then the outcome. So you have some degree of temporality with that. So one example of a cohort study would be food poisoning. So let's say you're a resident and all the residents get a delicious Thanksgiving pie because they worked on Thanksgiving. This may or may not be based on a true story. So let's say let's say of the 100 interns, 80 eat the pie. So you'll use those 80 that ate the pie as your exposure group, and then you could compare it, with the other 20 that didn't eat the pie as your control group. So you want to first identify the people who had the exposure, which is eating the pie, and then you'll look for how many of those developed food poisoning. All right, now our last study type, let's talk about an ecological study. So an ecological study is a study that compares population level data. So, using big data to assess for potential associations between exposures and outcomes. The big thing to watch out for ecological studies is an ecological fallacy. This is super high yield, and that's when you assume that group level trends apply to individuals when they really do not. So the unit of analysis for ecological study will be a population or a group, but you cannot apply these findings to the individual level. So ecological studies are good for generating hypotheses, but again, you will not be able to determine any causality or true associations for an individual based on an ecological study. So an example of ecological study would be comparing the average dietary fat intake with heart disease rates between different countries. So that's using that big population data. But if you were to find some, association with an ecological study, you can't make a conclusion about a particular individual with those results. So, if a high-fat diet was associated with increased heart disease, you can't say that for a particular individual in either country that eating less fat would lead to reduced heart disease. Again, that's an ecological fallacy. So let's talk about starting off with question number 1 now. I know a lot of you are watching these videos just for the question. So question number 1, a group of 10,000 non-smokers has followed over 20 years. So, and then half the participants work in environments with significant secondhand smoke exposure. So you're starting off with the exposure. So already, we kind of know this is likely a cohort study. And at the end of the study, the incidence of lung cancer is significantly higher in those exposed to secondhand smoke. Which of the following best describes this study type? So we know that we're starting off with the exposure, so it's not a case control, because with case control, you start off with a case. It's not a cross-sectional study because we're looking at these patients over time. And it's not an ecological study because it's not a population-level data. You're identifying a particular group that you're interested in. So it's either a prospective or a retrospective study. So a prospective study is when you start off with your cohort here, and then you follow them over time. So this will be prospective. Whereas a retrospective study is when you start here and you will look back in time at a particular cohort, but you'll already have the result prior to this point in time. So with a prospective study, you start off, let's say you are here, and you identify your population, and then you watch them over time. Whereas with a retrospective study, you go back and identify your cohort based on exposure, and then you see what outcomes they had. But you are able to do that analysis right away because you already kind of know the outcome. So this would be a prospective cohort study because we are starting off with our exposure group and then following them over time. All right, question number 2. Researchers survey 5,000 adults to assess the prevalence of hypertension and daily sodium intake at the same time. Which of the following is a major limitation of this study design? High cost, poor generalizability, cannot assess prevalence, cannot assess temporal relationships, or recall bias is inherent. So this would be you're using a kind of cross-sectional study because it's the same time. So you can only get a snapshot in time. So from this, it's not that expensive. It's actually cheaper. So not A, high cost. That's incorrect. B, poor generalizability. It actually could be generalizable. So we'll cross that off for now. C, cannot assess prevalence. Cross-sectional studies are actually best for prevalence. E, recall bias is inherent is incorrect because you're not surveying anyone. So the correct answer is D, cannot establish temporal relationships. Question number 3. A study shows that countries with higher per capita red meat consumption have higher rates of colorectal cancer. Which of the following best describes a major limitation of this study design? A, lack of a comparison group. B, inability to calculate incidence. C, exposure and outcome are measured in individuals. D, results may not apply at the individual level. Or E, susceptibility to interviewer bias. So let's think about this. You're doing a study of a large group or country. So this is a ecological study. So you want to know, now we want to know the limitation of the study design. And the main one that I would think of is ecological fallacy, or you cannot apply the results of the study to individuals. So let's see. A, lack of comparison group. Nope. B, inability to calculate incidence. Again, these are true, but that's not the major limitation. Exposures are measured individuals. Incorrect. So the correct answer is D. Results may not apply at the individual level. This is our ecological fallacy. Question number 4. In a study of 300 lung cancer patients and 300 matched controls, 180 patients and 90 controls report a history of smoking. What is the most appropriate measure of association for this study design? So you have your lung cancer patients, which will be your cases here, and then 300 matched controls. So this will be a case control study. So what is the correct measure of association in case control studies? Well, that would be an odds ratio. All right, question number 5. Which of the following public health questions is best answered using a cross-sectional study? A, does lead exposure cause developmental delay? B, is Zika virus associated with microcephaly? C, what percentage of adults have uncontrolled diabetes in 2025? D, is long-term alcohol use a risk factor for liver cancer? Or E, does HPV vaccination reduce cervical cancer incidence? So again, you want to think about a cross-sectional study. So again, that's your snapshot. And so A, does lead exposure lead or cause developmental delay? You can't answer anything temporal or causal. B, is Zika virus associated with microcephaly? Again, this would kind of be a causal association with Zika, and then whether or not it causes microcephaly after exposure. But C would be correct. What percentage of adults have uncontrolled diabetes in 2025? Because cross-sectional studies are good for prevalence. So it's a good study if you want to assess the prevalence of something. All right, question number 6. Which of the following correctly distinguishes case control from cohort studies? A, case control studies assess risk factors after disease status is known. B, cohort studies use odds ratios instead of risk ratios. C, case control studies are always retrospective and cannot assess exposure. D, cohort studies start with outcome and look back for exposures. Or E, case control studies cannot be used for rare diseases. So the best one, so again, case controls when you start with cases. So you start with your confirmed cases as a group in case control studies, whereas in cohort studies, you start off with an exposure and follow that cohort through time. So let's see. A, case control studies assess risk factors after disease status is known. Well, that's correct. So we already have our answer because, again, you start with confirmed cases, so you know the disease status when you start off in a case control study. All right, question number 7. A researcher observes that states with higher levels of air pollution have higher asthma hospitalization rates. What type of study is this, and what is its primary purpose? A, case control and hypothesis testing. B, cohort and cause identification. C, cross-sectional and prevalence estimation. D, ecological and hypothesis generation. Or E, randomized trial and intervention analysis. So going into this question, we have analysis of different states. So this is a large population or large group. So we already know this is kind of likely an ecological study. So that's likely the type of study. And the primary purpose of an ecological study is generation of hypotheses. All right, question number 8. Researchers use employment records from 1990 to 2000 to identify workers exposed to asbestos, then use cancer registries from 2000 to 2020 to assess lung cancer incidence. Which study design is being used? A, prospective cohort. B, retrospective cohort, C, case control study, D, cross-sectional, E, nested case control. So in this question, we're using employment records from workers that are exposed to asbestos. So we have an exposure here. So this is our exposure group. And then we're using cancer registries from the next 20 years to assess incidence of lung cancer among the different groups. So this would be kind of our result incidence. So because we're starting off with exposure, we know it has to be a type of cohort study. And because we already know the results based on the cancer registries, we can say that this is a retrospective cohort, rather than a prospective cohort where we would identify these patients or these workers and then follow them through time. All right, this next question will require a little bit of math, but question number 8. A group of researchers conducted a prospective cohort study to investigate the relationship between exposure to secondhand smoke and the development of asthma in children. They followed 2,000 children over 10 years. Of the 1,000 children exposed to secondhand smoke, 200 developed asthma. Among the 1,000 unexposed children, 100 developed asthma. Which of the following is the relative risk of developing asthma for children exposed to secondhand smoke compared to unexposed children? A, 0.5, B, 1.0, C, 1.5, D, 2.0, or E, 3.0. So to answer this question, we can first identify that this is a prospective cohort study, so we'll be calculating relative risk, and then we can make a 2x2 table where on the y-axis we have exposure and non-exposure groups. And the x-axis will have the group that developed asthma versus no asthma. So starting off with the top left quadrant, we see that 200 of the 1,000 children exposed to secondhand smoke developed asthma. So that would mean that they had both the exposure and developed asthma. And then that means that there are 800 that had the exposure that did not develop asthma. And then for the non-exposure group, 100 of the children developed asthma, and that means 900 did not. So to calculate the relative risk, essentially we just want to take the risk from the exposure and the non-exposure groups and compare them. So this would be the risk for the exposure group would be 200 divided by 1,000, because that's a total number of exposed children, which is equal to 0.2. And then compare that against the risk for the unexposed group, which is 0.1, and then you divide these and you get 2. So the correct answer is D, 2.0. All right, question number 9. I think this is our last question. A researcher conducts a study examining the average red meat consumption and colon cancer rate in 20 countries. They find that countries with a higher average meat consumption have higher rates of colon cancer. Based on this, the researcher concludes that individuals who eat more red meat are more likely to develop colon cancer. Which of the following best describes the error in this conclusion? So we can already see that this is a ecological study. And then the researcher tries to apply this ecological study to individuals. But again, the main error you want to watch out for in ecological studies is ecological fallacy, which is D. All right, maybe this is the last question. Question number 10. A case control study is conducted to investigate the relationship between exposure to a new diet pill and the development of acute liver injury. Researchers enroll 120 patients with confirmed liver injury and 120 matched controls without liver injury. Among the cases, 80 had used the diet pill. Among the controls, 40 had used the pill. What is the odds ratio for liver injury associated with diet pill use? A, 2.0, B, 3.0, C, 4.0, D, 5.0, or E, 6.0. So we'll make another 2x2 table, but again, this will be a case control study. So with a case control study, you'll be looking to calculate an odds ratio. So on the y-axis, we'll have our cases of liver injury against our control. And then on the x-axis, we'll have our, confirmed case or exposure. So these will be the patients who used the diet pill against those who did not use diet pill. So starting off with the top left quadrant, we have our confirmed cases that did use a diet pill. So we see that of the 120 patients that had confirmed liver injury, 80 used the pill. So that means there's 80 here, and 120 minus 80 is 40. So 40 of the patients who were confirmed cases did not use the pill. And then on the other side, we have among the controls, 40 of those patients had used the pill that did not get liver injury, and 80 did not use the pill. So now we need to calculate the odds ratio. And you might remember the odds ratio you can calculate using the kind of fish. So it ends up being AD divided by BC. So we use this fish, so it ends up being 80 times 80 divided by 40 times 40. So I think we can do the math, and this ends up being like 4 because this ends up being 2 times 2, which equals 4. So again, we kind of do this fish, and we have the correct graph that we made. So, and C4 is indeed the correct answer. So that was our last question. Thanks everyone for watching, and make sure to like, subscribe, and share if you haven't already. All right, see you in the next one. Peace.